Hi everyone, in this lesson we're going to be looking at the cosine rule. And the cosine rule is shown here. Another way of writing the cosine rule is also shown here. And just as a reminder, these formulas are in your formula booklet. If you go to topic 3 in the formula booklet, you'll see that we're showing the cosine rule written when you're solving for a side, or the cosine rule written when you're solving for an angle. So we'll do a couple of just basic application problems using the cosine rule, and I'll show you how to use your calculator as well. It says find BC, round to the nearest tenth. And so we're going to write out the formula. I'm just going to label my sides to start. Across from angle A is side A, across from angle B is side B, across from angle C is side C. And I'm being asked to find side BC, so that's going to be side A. So I'll write out the formula first, and we'll just fill it in. And at this point, we'll put it into our calculator, and just remember that when we solve for A, we need to be sure to take the square root of both sides. And we put that in our calculator, we're going to get approximately 17 centimeters if we round to the nearest tenth. And I should have said this at the start, but make sure you're in degree mode. You can see at the top of my screen that I am in degree mode. If you aren't and you need to change that, you go to mode, and you're going to go down and you're going to highlight degree. So we're going to get A is equal to, of course, side BC. Rounded to the nearest tenth, we got 17.0 centimeters. Okay, moving on to example 2. This time we're finding an angle, so we're going to use the formula where we're looking for the angle. So we're going to have the cosine on the left side of the equal sign. So we're looking to find angle A. So we're going to write out the formula first. And before I fill it in, I'm just going to label my sides. Across from angle A is side A, across from angle B is side B, and across from angle C is side C. And now we can fill in the formula. All right, so if we put the right side of the formula into our calculator, we're going to get a decimal value. So let's go ahead and do that first. And we get this 0.746031,746. And what we need to do now is we're going to take the inverse cosine of both sides in order to solve for A. So if we take the inverse cosine of both sides, we're going to get just A on the left side, and we're going to get the inverse cosine of our decimal value. So let's go back and do that. So we're going to take the inverse cosine of our answer, and that is going to give us approximately 41.8 degrees. All right, so now that we have the basic understanding of how to use the cosine rule, the cosine law of cosines, we're going to look at some more difficult problems, something more likely that you would see on an IB exam. So we have a ship leaves port at 2 p.m., traveling north at a speed of 30 kilometers per hour. At 4 p.m., the ship adjusts its course 20 degrees to the east. How far to the nearest kilometer is the ship from port at 5 p.m.? And we're going to round that to the nearest tenth. Okay, so first of all, we need a good diagram. I just want to make a little note over here off to the side that this is our directionals. We have north, south, west, and east. And I always would say to my students when I'm teaching geometry, it's really important that we do a good diagram and make your diagram sizable, that you can really read your writing after you fill it in. So don't make a little tiny diagram. Make it, make it bigger, okay? Use the paper. All right, so we know that the ship leaves port at 2 p.m. and is traveling north. So we're traveling this way, okay? The ship is traveling north at a speed of 30 kilometers per hour. Right, so the first part, we start at a port. I'm just going to make this. I'm going to say this is the starting position. This is where the port is. And then I'm going to travel north starting at 2 p.m. at 30 kilometers per hour. Okay, so then this is my second position. And then at 4 p.m., I'm going to change position. So I had 2 hours where I was traveling from my first position to my second position. And in those 2 hours, I'm traveling 30 kilometers per hour. So this distance here to here is going to be 60 kilometers. Right. Then at 4 p.m., I adjust my course and I'm going to go 20 degrees to the east. So from the north, 20 degrees east. So this is 20 degrees. Right. And so my next position ends here. This is my final position. How far to the nearest kilometer is the ship from the port at 5 p.m.? Okay. So from 4 o'clock to 5 o'clock, I traveled from position here to here. So I traveled 1 hour. I know that this distance here is going to be 30 kilometers. And I want to know how far is the ship from port at this point. So I want to know from the final position to the port. I want to know that value there. Okay, so I'm going to call that value, I'll call it letter A. Right, so I know the measures of 2 of the sides, and I know that this angle is 20. Now, all the way to here forms a linear pair. 180 minus 20 is going to give me 160. So let me write that in, 160 degrees. So I have a side, I have an angle, I have a side. I now have enough information to use my cosine rule. So let me write it out. It doesn't matter which side you call B and which side you call C. I'll just go with, I'll call the side that's 60 B and the side that's 30 C. And in order to solve for A, we're going to take the square root of both sides. So we'll put this in our calculator. And if we do that, we're going to get A is approximately 88.8 kilometers. Okay, moving on to example 4. John stands between 2 buildings. There's John. And the buildings are different heights. He's 46 meters away from the building on the left. This value here. And the angle of elevation to the top of the building is 33 degrees. The building on his right is 28 meters away. And that angle of elevation is 17 degrees. Round all answers to the nearest tenth. Find the heights of the 2 buildings. All right, so first of all, I'm going to label the height of this building A, and I'm going to label the height of this building B. So we're going to find the heights of the 2 buildings. Here's my reference angle, and I have adjacent and opposite, so I know I'm going to use the tangent. So the tangent of 33 degrees is equal to the opposite, which I'm calling letter A, over 46. So if I cross multiply, A is equal to 46, the tangent of 33 degrees. And if I put that in my calculator and round to the nearest tenth, I'm going to get 29.9 meters. Okay, that's the height of the building on the left. Now to find the height of the building on the right, I'm again going to use tangent because I have opposite and adjacent. So the tangent of 17 degrees is equal to the opposite, I'm calling letter B, over 28, cross multiply. So B is equal to 28 tangent of 17 degrees. So B is approximately 8.6 meters. All right, so I've taken care of letter A. I've found the heights of the two buildings. Now it says find the distance from the top of one building to the top of the other. All right, let's see here. So I'm trying to find this distance here. Now I want to use my cosine rule. I think that will be the easiest. So I need to know this angle. Well, this angle is going to be whatever 180 minus 33 minus 17, because all of those angles added together make a line. So in order to find that angle there, I'm going to do 180 minus 33 minus 17. And when I do that, I'll get 130 degrees. Okay, great. So this angle is 130 degrees. All right, now I need to know the measures of this side and this side in order to use my cosine rule. So I'm going to call this side letter C, and I'll call this side letter D, and then I'm going to use more trig to help me with those. Now remember, we can use trig here because we have right triangles. Okay, so for part B, before I even get into finding the side I need, I'll call that side letter E, I have to find C and D. Now, in order to find C, here's my perspective angle. This side's adjacent. This side is my hypotenuse. Well, the trig function that uses adjacent and hypotenuse is cosine. Right, so the cosine of 33 degrees is equal to the adjacent side over the hypotenuse. In this case, I'm calling that C. Cross multiply. So we're going to get C cosine of 33 degrees equals 46. So solving for C is 46 divided by the cosine of 33 degrees. All right, so C is approximately, when I put that in my calculator, 54.8 meters. So let me just write that in here, 54.8 meters. Now I need to find side D. Well, my perspective angle is here. I have adjacent, and I'm looking for my hypotenuse. So again, I have to use the cosine. So the cosine of 17 degrees is equal to the side that's adjacent over the hypotenuse. I'm calling that letter D. Cross multiply. We get D cosine 17 degrees equals 28. Solve for D. Divide both sides by the cosine of 17. If we put that in our calculator, we're going to get D is approximately 29.3 meters. All right, let's fill that in. 29.3. All right, now I have enough information that I could use my cosine rule. So I have side, angle, side. All right, last step. Take the square root of that, both sides. Put that in the calculator. And when we solve that, we're going to get E is approximately 77 meters. A lighthouse keeper spots a yacht 15 kilometers away on a bearing of 70 degrees. There is also a rock 9 meters from the lighthouse on a bearing of 210 degrees. How far is the yacht from the rock round to the nearest 10? All right, so some of this picture is already marked up. I just want to make a little note here that this line continues. So the lighthouse keeper spots a yacht 15 kilometers away at a bearing of 70 degrees. So if that's 70 degrees, then from here to this line, right, is going to be 100 degrees. All right, that takes care of this and this. There is also a rock 9 kilometers, it's already marked on our picture, from the lighthouse on a bearing of 210 degrees. So let me do that in a different color. A bearing of 210 degrees. So this is 210 degrees. Now, from here to here, remember, is 180 degrees. So this little piece right here is 210 minus 180. So 210 minus 180, that's 30 degrees. All right, so let me just put a little note in here. I'll do that in blue. This piece right here, that's 30 degrees. All right, so this entire angle then, we can really clearly see because we've really done a good job of, sketching this out, that blue angle is going to be 110 plus 30. So that angle there is going to be 140 degrees. Okay, so now we have side, angle, side, and we can use the cosine rule to find how far the yacht is from the rock. And I'm going to call that value, I'll just call that x. Now notice that my diagram is very clearly marked, that as we went through each step, you could see what I was doing and you could read my writing when I was done. As small of a thing as it seems, those details, being meticulous and careful and being able to read your own writing when you're done, make a huge difference in understanding how to solve this problem and to, use the right angle and the right value of the sides. All right, so let's fill that in. So we take the square root of that. The value of x we're going to get is 22.6 kilometers. All right, everyone, that's all I have for this lesson. Thanks for watching to the end. Have a great day.